Okay, so I am going to go ahead and take a shot at Kubernetes the hard way. I've recently accepted a job where I'm going to be working on Kubernetes, so it'd be a good thing if I understand how to do it. So I'm going to try to follow Kelsey Hightower's guide on Kubernetes the hard way. I've already read through the introduction, the target audience, and all that. There's all these different labs, so let's try the prerequisites. I already went ahead and signed up for a Google trial. A little disturbing that they already have my payment information for other things, and they're more than happy to go ahead and charge for this when the time comes. Okay, now I want to install gcloud. So let's figure out how to do that. Hey, install for Windows. Sounds like a winner. I think I want to do it for Windows. Alternatively, I could do it as Ubuntu and do it through the Windows subsystem for Linux, but I'm going to do it this way. So I'll create a platform project. That's interesting. So we're going to do that. Okay, apparently I've done something before. Friendly Beach. That must be an automatic naming thing. Friendly Beach 241917. Alright. I'm just going to create a new project here. Okay, Kubernetes the hard way. Sounds great. Widget 241917. It likes that. Okay, it's taken a little while for that to go, and then it's going to be download Google Cloud SDK. So let's grab that. No thanks. Bundled Python. Pretty sure I've already got 2.7 here somewhere. Whatever, we'll just let it do its thing. That's one of my things I don't like about Python, the whole rift between the 2 series and the 3 series, and both are still very prominent. I know I've got 3, it's just a question if I have 2 running in tandem. Okay, let's see how this is going. Hey, project is created. I don't know if we'll actually use that or not. Looks like we'll want to make sure that we've got right version, which I'm sure we'll have the latest. Set a default region. Okay, well, we'll do that in a minute. Okay, it's been installed. Whatever, do all the things. Yeah, we'll even let it run init. Okay, you must log in. Would you like to log in? Of course I do. Should I trust it? I guess I will. Okay, I'm now authenticated. Sounds pretty fancy. So let's go back to the guide. It says we should have been able to do that. Okay. So it should already be set. This will be interesting. Let's see what happens. Okay, never mind. Pick a cloud project to use. 3. Alright, so let's look at gcloud config. Is that just going to show us? How about list? Okay, I don't know if it's actually got me with a compute region. I wonder, can I just get that? I just want to see what it has. Looks like it's get value unset. Okay. Well, I want to set a compute region, but here we go. Being in Michigan, I'm going to want something more east friendly. Not enabled. Okay. I don't know what that is or why it takes a few minutes. I'm not going to use tmux. Okay. So here's where I may want those tools for the Windows subsystem for Linux. So if I do, this might be available. Hey, what do you know? It might even work. So I'm going to do this. All right. Yeah, maybe I chose a bad spot to do that. Oops. What did it grab? Where did it grab it? Show progress. Did it do something? CFSS. Nope. Interesting. So I didn't even put it in here? Where are we now? Okay, I'll try it again here. Okay, that definitely looked like it behaved a little bit differently. Yeah. Oops. Oh, come on. There we go, finally. I'm going to make both of those executable. I wonder, do I have a... it looks like I do have those folders, so it's got some pseudo folders. I might as well just cheat a little bit here, copy paste. All right, got that. Got that. Okay, CF, SSL. Version. It's got some stuff. Okay, I'm going to jump over here again. Okay, it's got some stuff. US West, US East. I think I want to do US East 1. So let's jump back. What was the suggestion? Set a default compute region. So we're going to do something like this. I'm going to try it from my Linux window just to make sure we're all good. turn down the volume on that. That's getting annoying to me. Okay, East 1. Let's take a quick anonymous survey. No. And then we'll, why not? US East 1B sounds like a great compute zone. Updated. All right, so we should be solid there. Okay, we've got the tool. Now we need to install kube control. And yes, I will call it kube control. I know some people call it kube cuddle, but I heard the guy who actually wrote the initial pull request for this, and he called it kube control. So that's my argument for why I'm going to call it that. Okay. Okay, so we've got it copied to user local bin, and we're going to make sure that it looks like it's running. Oh yeah. I'm going to take a moment here and just up the size a little bit. I'm getting old. There we go. Much more better. Okay. Now we're going to provision some resources. Put that free subscription to work. Okay, we set the zone in the region. Flat network. In which containers and nodes communicate with each other. Yeah. Okay, so we're going to create a VPC called Kubernetes the Hard Way. So Google Compute Networks create, okay, giving it the name custom subnet mode. Error. You do not currently have an active account. Right on. Love it when they tell me what I need to do. Okay, go to the following link in your browser. I'm actually going to do that in a browser up on my other screen just because I don't know what it's going to pop up. I don't want the world looking at my credentials. Please copy this code, switch to your application, and paste it there. Yeah, we're just going to turn off my screen for just a second, because I don't know how tricky these things are. I'm now logged in. Current project is none. Where? I'm just trying to remember exactly what my project ID was, because it had the weird numbers in the name. Set project ID. Okay. We're going to clear that screen. I did not mean to click that. No! Stop. Go away. Okay. Back at it. Alright, so I'm pretty sure the last time we tried to run that command, it failed. So let's try this again. Ooh, it looks like it's doing stuff. That's exciting. Let's see what happens if we come over here and look at it. Oh, I see compute engine service agent. Well, it looks like they've definitely got it figured out how they're going to charge me money. So that's the important bit, right? Da-da-da. Oh, and it looks like this is my created Kubernetes the Hard Way. Oh, that's the project. That's not the resource we're looking for. Okay. Okay. Either way, it's there. This is the first time I've ever tried using the Google console, so it's going to be a little different, but I'm going to create the subnet now. So using 10.240 with a 24 mask. So we're creating the subnet named Kubernetes on the network Kubernetes the Hard Way. At least that's how it looks like that would be interpreted. All right, came back pretty quick. Okay, firewall rules. So, creating a firewall named such and such, which is going to allow all the addresses in the subnet we just created and some others in a 16. My CIDR math is not the best. I'm not quite understanding what the ranges are there, but hopefully it'll be explained here in a bit. Because I don't want to have to figure out. Seems like there'd be overlap there, but maybe not. You know what? Yeah, it's done. We're good enough. No, I'm too curious. This looks like a class act. If we take, oops, if we take this, give it a mask of 24, that's going to go from 10.240.00 to 10.240.0255, and then if we do, was it 216? Yeah, 10.200.00 with a subnet mask of 16. That's going to go from 200.00 to 200.255.255. So I was way off. Oh yeah, because those are both multiples of 8. So if you're not familiar with CIDR math, it's going to be multiples of 8, or I should say powers of 8. No, multiples of 8. So you've got 4 tuples there, or four segments, and so 16 means that the last 2 can be anything, whereas the 24 that we were at, if we switched this one to a 24, it's just that last one. So that says that the first 3, 8 times 3, the first 3 are locked in as exactly what you said, and that last one, when applying the mask, the wildcard mask, which is the equivalent way of saying it, saying, yep, that last one can be anything from 0 to 255. 16, the first 2 are locked in. And if we went to a 8, it'd be just that first, just the 10 dot whatever. And then if you do 1, or if you do a 1, then you've got slightly different limits. I think that's just based on what's allowed as a public or a private or whatever. But we're going to be done with that. Okay, now we're going to allow external SSH. So source range is anything. So this is doing a /0. So absolutely anything can SSH or ICMP or HTTPS connect. So So the /1 was a little different. For whatever reason, they didn't have a /0, because I'm assuming they probably just were under the understanding that you would just know that a /0 it's exactly nothing. So everything can change. Direction ingress, yeah. All right. External load balancer will be used. So we're going to list the rules that we've created. Okay. This, I wonder if there we go. That's a little better. Okay, so ICMP, the default network is allowed. Which one is the default? Yeah, we'll figure that out. SSH, RDP, yeah. So this must be anybody, anything, and then our network we defined as Kubernetes the Hard Way has some other stuff as well. Okay. Looks like there's some overlap of some stuff. Well, except here I think it's saying any TCP, any UDP, any ICMP for in our network, allow it. Okay. The output shown here is a little different than what we're seeing, but I'm going to think that's okay. Okay, so we need a static public IP. Oops, I copied that. So we're going to get an IP address. Now we're going to grab that. All right, we've got a public IP address. How exciting. Okay. This, I'm assuming, is going to take a little while, but it looks like we've got... It's doing a loop there. And so... going to create something called controller 0, 1, and 2. Oh, it's saying async here, so I wonder if it'll just, let's look at that command. Yeah. So it's probably still provisioning it in the background. I have a 200 gig disk using Ubuntu 1804. N1 standard one. I don't know what Google's machine types are. Let's actually look at that real quick. We'll see what type of compute and memory it has for that. All right, so that is, looks like that's just the bottom of the bottom for them. So it's 1 core, 3 3/4 gigs of RAM. So not terrible. And yeah, it looks like they've just got a simple convention where hitting that last digit there is the number of cores. It looks like every time you double the cores, it's also doubling the RAM. So 3.75 times the number of cores gives you the RAM for the N1 standard series. Oh yeah, and then they've got a high mem. Okay, interesting. Yep, and it's assigning it to our subnet, so it's going to be, okay, so the controllers are going to be at 10.240.10, 11, and 12. I don't know what these scopes are for. Okay. Oh, yeah, here's where it assigns the network, and then here it's assigning it to this, or the IP, so it's a static IP address for it, and then it's using a subnet of Kubernetes. It's got a tag of Kubernetes the Hard Way, and it's a controller. Okay, so those are the controllers. Create 3 controllers, yeah. Each worker instance requires a pod subnet allocation. Okay, the pod subnet allocation will be used to configure container networking. Pod CIDR instance metadata will be used to expose pod subnet allocations to compute instances at runtime. Alright, so we're doing 3 compute instances, very similar to before, except this is in that 200 range instead of the 240 for the pod CIDR. Interesting. Okay, so it's giving it a 200 range for the pod CIDR, but then it's got a private network IP of 240, 0, 20, 21, and 22. It's not quite clicking yet as to why that exactly is happening, but once we actually have some traffic flowing through, it might make a little more sense, kind of how things are hopping around. Okay, so we've got a bunch of stuff running in the background. I wonder if I look at the project here again, I just don't know how to get into... What? I don't know how to look at resources. I just want to see like just a list of resources that are being allocated. I am most certainly not seeing that. Okay, what evs? Let's just get back here. Okay. Well, this is going to list stuff. I wonder if all of these will even be done yet. Yeah, it says they're up and running. That was pretty quick. Okay, so we see our internal IP addresses 10, 11, 12, and then 20, 21, 22. They're all in East 1B. Controller 012, worker 012. Alright, they've got some public IP addresses there. Okay. So we're going to SSH to controller 0. It's your first time. SSH keys will be generated. Enter a passphrase at the command prompt. Why not? Okay. I like that they automatically generate the keys for you that first time. That can be kind of a pain in the buttocks. Okay, is this any different? Oh. This is just having me enter what I just gave it as the passphrase so that I can use it again, I think. Oh, okay. I don't know why I had to enter it twice. It may have been... It said I was waiting to propagate, but so maybe it just wasn't there yet. But anyway, it looks like we're on that machine now. Okay, yep, we did that. That all looks familiar. Oh, and then we're connected. Now we're going to just disconnect. So, okay, cool. Okay, we need to create a CA, some certs. Okay, in this section you'll provision a CA for TLS certificates. I don't think that's right. I think that's a glitch in the doc, that extra curly brace there. So we're creating some information. We're using this key as a signing key, an encipherment key, server authentication, and client authentication. So it's going to be able to encrypt secrets and sign other certificates and be used for mutual TLS. So we're creating a couple files. So we're going to sign it as though we're from Portland, Oregon. Whatever. I think that'll be just fine. Yeah, and here's a closing curly brace. I'm wondering if that was in the markdown. I was supposed to group it off or something. Okay, so it's going to say generate a cert from csr.json, which was the first, or no, the second file we created there. And then it's going to call cfsslJSON bear CA. It's a bear CA. All right. We've created a certificate. And we should see, yep, CA key PEM and CA PEM right on. Okay, we're going to generate client and server certificates. Certificate for the Kubernetes admin. Okay. I'm guessing this is for the dashboard. I honestly don't know. As I said, I've never actually used Kubernetes before. I've read documentation about it. I've heard podcasts about it. But that is it. Okay, and we've got our admin key PEM and admin PEM. Okay, Kubernetes, or the kubelet client certificates. Okay, so for each of the workers, we're going to create a certificate, it looks like. Okay, so let's read a little bit about this. Kubernetes uses a special purpose authorization mode called Node Authorizer that specifically authorizes API requests made by kubelets. In order to be authorized, Node Authorizer kubelets use a credential that identifies them as being in the system nodes group with a username of system node name. Okay, so each worker node is going to have a separate identity that it's going to be registered through this certificate. Yep. So we're going to need to grab all that stuff. It's going to loop through this and do it for each node, worker 0, worker 1, and worker 2. Takes a little bit of time. The idea there is, the longer it takes you to create the certificate, the longer it should take to hack it. Okay. Okay, the Kube Controller Manager client certificate. Okay, we created an admin. Now we've got a Kube controller. We've got certificates for each of the workers. Oops. No. Oh yeah. I saw that there's that extra curly brace again. Still copied it at the bottom. Okay. Kube proxy. So, the way I understand it, the proxy is what's allowed to redirect the traffic from the outside to inside for the services. Okay. We've got lots of certificates. Wow. Thankfully, they're all just self-signed certificates. Okay, generate the Kube scheduler client certificate and private key, which is how we've been doing these. Yeah. If I get around to it, I think I'm going to submit a pull request to remove these curly braces. I don't think they're supposed to be there. At least it's not how I normally write bash. It seems to be working without them at least. Okay. Kubernetes API server certificate. Okay. The Kubernetes the Hard Way static IP address will be included in the list of subject alternative names for the Kubernetes API server certificates. Okay. This will ensure the certificate can be validated by remote clients. Okay, so this is that static public IP address. Okay, and we're going to allow it to be able to be hit by IP name. Okay, and here's where we're grabbing that address so we can have it assigned. Right on. I forgot what that thing was. Yeah, there we go. So now we've got Kubernetes public address variable. Wow, okay, we're almost to the bottom here. Generate the service account key pair. Okay. That's a lot of certificates. Okay. So now the certificate authority that we created, we're going to copy that and the key pair for the worker to that worker. Okay. It's just putting it in their user home directory. It's not putting it under like .ssh or anything like that. I wonder if that's something we'll configure for it to look just in the home directory, or if that's just the default for Kubernetes. Okay. Okay, so it copied the CA and the worker key pair. We do that for 1 and 2. All right. And doing the same thing. Well, actually not at all the same thing. For the controller, we're copying all those other certificates as well, including the private key for the CA. find it interesting that I tried to SSH to one node and it set up a key or key pair, and now I can use that for anything out there. I'm just kind of wondering how I'd handle that in an environment where I maybe had different levels of access. You know, I want to be able to create a bunch of compute nodes, but some of them can be used by developers, some of them can't, some of them are just for operations, you know, whatever. Okay, so we've got all the client certificates. All right, configuration files. So we've got the certs out there. Okay. So we're going to create some kubeconfigs so that they know how to find each other. Okay. We create configs for controller manager, kubelet, kubeproxy, scheduler, and admin. Okay, we've already got the public IP address. Okay, and so that's, yeah. I'm certain that's the exact same command we ran before. Let's just see what happens. We'll let that run. We'll run that again. Yeah. Still the same format, all that. Okay. Node name must be used. Okay, and the node authorizer, yeah, because the certificate was based on that name, so that makes sense. Okay, so we're setting cluster. Set cluster. Okay, so we're telling it that the cluster is worker 0, worker 1, worker 2. Setting the credentials based on their key pair. And adding them. Okay, that was what I talked about earlier, the user being system node and then the instant name. All right, and then telling it to use that kubeconfig that we're creating right here. I'm going to admit I don't understand everything I'm doing here, but this doesn't really seem like the hard way as much as just the annoying way. Yeah. But that's because I'm not completely understanding everything I'm doing. I can copy and paste like the best of them. Okay, now we've got kube control, set cluster. Okay, so this is for the proxy. Proxy key pair. I wonder what happens if I copy this, these curly braces. I guess it still works. Squirrely braces. That's what they are. They're squirrely braces. Okay, so we've got a. Are these local? Yeah, there they are. Okay. So it's creating the files locally. Okay. Kube controller manager. So this has got a loopback address. Giving it the CA. Controller manager, key pair. All right. Okay. So I was a little thrown off. I was thinking it was actually doing stuff out on the nodes, but it was weird that I'm not specifying nodes here. I thought I was, for the first one, but yeah, nope, it's just saying create the config with that name, not actually connecting out to the node. Okay, so that's making a little more sense. Okay, and the scheduler, we're going to do the same. So the bits that are changing are like the server. So a couple of these are saying localhost, whereas the other ones, the earlier ones for the proxy was saying, oh yeah, I live at this special port on the public IP address, and yeah, that's the same IP address. Never mind. I was thinking that was the proxy IP address. Again, it's not completely clicking with me yet, but hopefully we'll get there. Yeah, we had a couple that were looking at the public IP address, a couple looking at localhost. Okay. Another one looking at localhost for the admin. And sometimes their certs are different. So that's for their credentials. Makes sense. Okay, now we're actually going to send these configurations out. And so we're going to put them onto the worker nodes for the worker configs. Makes sense. And we're going to give it the proxy config. Okay, so the workers get their config and the proxy config. I'm regretting putting a password on this certificate. When I used to do this all the time, connecting to different servers, I'd have the agent running, but I can't remember how I did that before. I went from doing Linux for years and years to doing Windows for the past couple. I've completely forgotten half the stuff I did before. Okay, so now for the controller nodes, they get the admin config, controller manager, scheduler. All right. And then all the controllers have the same config. I'm assuming that's because the workers have to identify themselves for the work that they're doing, whereas controllers can just go around and do whatever they want. Maybe. I'm probably oversimplifying that. Okay. Data encryption. Okay, so we're just creating a random 32-bit key. An encryption config YAML file. I wish there was better tooling for YAML. I want to like it. But compared to JSON, there's just a lot more tooling for JSON. Okay, and then we're going to copy that with our randomly generated value out to each of the controller nodes. And again, one more time. All right. Okay, etcd time. Okay, so cluster state is in etcd. My understanding of etcd is it's a highly resilient key value store. So it's a NoSQL database of the key value variety. Okay, so we're going to do a 3-node etcd cluster, configure it for high availability and secure remote access. Okay, so we're going to SSH into controller 0. All right, we're connected in. Yeah, but I don't have Tmux because I'm in Windows. I'm excited about the new Windows terminal though. We're still, if I was to do this in a month from now, I'd have that, but not today. Okay, so we're going to install the etcd binaries. Okay, grabbing the stuff. Wow. Super fast. Okay, gonna extract it out and move it. Configure it. Okay, so copying the CA our Kubernetes key pair. Okay. Internal IP will be used to serve client requests. Metadata flavor Google. That's interesting. Okay, so we've got the internal IP address. What are we going to do with it though? The host name. etcd service. So there's a lot of stuff here. I'm just going to eyeball this real quick. So we're setting up all the certificates. Telling it peer client cert auth. Client cert auth. So I'm assuming that's just telling it how to authenticate requests. Advertise peer URLs. So it's got that internal IP address on port 2380. I'm totally going to forget that port, but I'm sure it'll pop up later. Okay, it's telling itself about the cluster being on each of the controllers. Restart on failure, but wait 5 seconds between restarts. Okay. Okay, I do that. I think I'm going to go ahead and create some more instances. It's not going to be quite the same as getting your keyboard output connected to all the things. Oh, that's Ansible stuff there. It does not have my most recent history. This is going to be controller 1. Controller 2. Okay, so we want to get it. Same as before, untar that thing and move it to be where it belongs. Copy the certificates. Grab IP. Host name. configuration. All right, and now let's go ahead. Okay, so we're going to set etcd to run on start. So 0, 1, and 2. Oops. 1. Okay. So list the etcd members. All right. So it looks. What do you know? It looks like so I'm on controller 0 and it's showing me that it knows about 2 and 1. I'm hoping that's because they're actually running. It is possible that's just because I'm going to assume that this is showing the information because they're actually running. And not just the fact that we put it in the config to tell it, oh yeah, and this is what your cluster should be. Okay. All right. This is exciting. So we've got a way to persist data. Okay, now we're going to create the control plane. Okay. So we're going to put these components on each node. API server, scheduler, controller, manager. Okay, so and because we're lame, we're gonna just copy paste this across all the things. Okay, we're going to grab some binaries. Okay, so the control plane has these. Following components will be installed on each node. Okay, so each node will have an API server, controller manager, scheduler, and kube control. All right. Alright, got the stuff. Gonna move all those to user local bin, make them executable. So it wouldn't be any fun without that. Okay. Move in the certificates and our encryption YAML. Okay. Makes sense. I'm assuming this is just a magic directory that Kubernetes likes to hang out in. Okay, again, we're grabbing internal IP address. Creating some configuration for API service. Okay, so what's interesting here? So this looks very similar to the other config we created. So it's saying what its advertising IP address is. It's binding to all available ports and IP addresses. I shouldn't say ports, but just any available network interface it's going to bind to. It's talking about the etcd servers, so we know we're calling those out explicitly here, which makes sense, since that's where you'd go to look anything else up. Experimental encryption provider, eh? Let's looking at that encryption config that we dropped out in the varlib Kubernetes folder. It's telling it about the certs to use, saying yes, we should use HTTPS. Runtime config API all. Cluster IP range. I wonder. That's a new address range, I think. I don't remember 10.32 popping up before. Okay, and it's got port range and the TLS certificates it's going to use. Right on. Okay, controller manager. So we copied our config out there earlier. Now we're actually gonna get it in the right spot. When we did the SCP, we could have done that directly to that folder. That would have been a little smoother, but whatever. We gotta learn, right? Okay, and here it's telling it about that 10.200 range. And so that's where it was saying we've got the 16. It's got the signing certificates, or the CAs, service count key. It's got that 10.32 again. It's just surprising. I don't remember us setting anything up as far as subnets or anything for that. So I wonder if that's just something special for Kubernetes. Like it just really likes that range. Okay. Kube scheduler. This is interesting that we are creating the config out there right now. Okay, so scheduler v1 alpha 1. That's something I'll have to learn about, is how new APIs get rolled out and what the differences are, where I can follow release notes on those and such. Okay, so it knows where the config file is, but we have to create this YAML. So leader election true. I'm assuming alternatively I could just specify a certain IP address of who the leader is. Scheduler.service systemd. Okay. So creating this so that it'll automatically start up, I'm assuming. Yep. Yep. Okay, for the scheduler. Making it so the scheduler will start with system startup. And let's go ahead and start it. So this is going to start the API service, controller manager, and the scheduler. Allow up to 10 seconds. More than 10 seconds. I'm not waiting for you. Okay. Last one. All right. Enable HTTP health checks. Okay, Google Network Load Balancer will be used to distribute traffic. We keep talking about this load balancer. We've not created it yet, though, I don't believe. We're going to do it. Wait, what? Okay. Network Load Balancer for Google, but also Nginx. So I guess we'll wait and see how we're using Nginx. Okay, agree API servers and allow each API server to terminate TLS connections and validates client certificates. Network Load Balancer only supports HTTP health checks, which means the HTTPS endpoint exposed by the API server cannot be used. As a workaround, the Nginx web server can be used to proxy HTTP health checks. Okay, now I'm on board. I should have just read for a second. In this section, Nginx will be installed and configured to accept HTTP health checks on port 80, proxy the connection to the API server on HTTPS at port 6443 healthz. Okay, no authentication is required for that. Okay, so we need to install Nginx on each of these. Yeah. And of course, you can't put all these as one thing for me to copy paste. Yeah, maybe. Nah. Yeah, I'm gonna do it. This is something I actually feel comfortable with. Okay, so let's look through it anyway. So it's saying, yep, when you get in a request for /healths on port 80, forward it on. It's saying this is the cert to use. And then we're moving that file, creating a symlink. Yeah, so that site is enabled. Okay. And I definitely think it's been more than 10 seconds by now. It's going to take a little bit of time to download and all the stuff. It's installing. I actually hadn't used Nginx for quite a while. I used Apache for a long time and I just got used to it always being everywhere. So it was nice that you didn't have to do this. You didn't have to install stuff. But there are some things I really like about Nginx. I like the built-in snippets capability where you can have kind of shared configurations. So for example, you could have your signing keys or like your server keys in a separate spot and have multiple sites use those from that one shared location. Okay, what was the last thing it did? Well, that didn't do what I wanted. That just did the first part. I was hoping it would do all the things. Okay. Okay. That's the way we gotta do it. Okay, so we copied our file out there. We're gonna link it to make sure it works. And we're going to go ahead and restart it. And turn it on So it fires every time the system restarts. Okay. Now we can do this. So get component statuses using admin kubeconfig. etcd is healthy. Controller manager, scheduler. Doesn't show API. Was it supposed to show API? Doesn't look like it. I mean, I'm assuming it's hitting the API in order to even do this, so meh. Okay, test the Nginx health check proxy. Right on. Okay. Yep, we ran it on all three. Now set up some role-based access control to allow the Kubernetes API service to access the kubelet API on each worker node. Okay, so the kubelet API is going to run on the workers, but our controller, we need to have the Kubernetes API server be able to access that. I'm trying to make sure I'm connecting the dots in the brain. Okay. So authorization mode, webhook. Okay. Kubelet API server to kubelet. So we're on controller 0. Probably again, this is a do it on all three controllers. So RBAC authorization. It's a little concerning that there's beta and all this stuff, especially for things like authorization. Not my favorite place to see a beta. But it's saying auto update, bootstrapping, RBAC defaults. And I can get to proxy stats, logs, spec, and metrics. Okay. I'm guessing it just created that for the whole cluster. Kubernetes API server authenticates to the kubelet as the Kubernetes user using the client certificate as defined by kubelet client certificate flag. Where? Or is that down below here? I don't see that flag. Or is that a I'm hoping that's a reference to a flag that we'll use later on. I'm assuming so. Like maybe that's like when you call kube control, you can pass that flag. Because I'm just not seeing it. Okay. So we created another. This is the cluster role binding. Yeah. Okay, the front end load balancer. In this section, you will provision an external load balancer to front the Kubernetes API servers. Static IP address will be attached to the resulting load balancer. Okay, so I think we're now finally going to create that load balancer. Okay, so we've got the public IP address. Okay, it's saying create health checks. At that /healthz endpoint. I don't know what this is all about. I wonder if those are just some particular IP ranges that are used in the Google Cloud. That'd be my guess anyway. Okay, it's going to add controller 012 to the target pool. Okay, and there's that port 6443. All right. So it's creating forwarding rules to go from our public IP to the target pool, which is going to have the controllers in it. All right. And unless we do something later, I'm assuming that we're just doing round robin load balancing here. So we've got everything on everything. I'm going to do this from my local machine. It's doing stuff. You do your thing. I do appreciate the repetition of the setting the IP address, just in case you jump in kind of midway. Trying to figure out where we are. So we set the health check. We set an ingress rule. Yep, assigned the target pool. Set up the forwarding rule. Great success. Okay. It's interesting that it's telling us more about Git than anything else here. That's the version information is related to Git. Okay. Okay. All right, so I'm going to take that as we're good with the controllers. So now we want to have the workers. The workers. Okay, so I'm going to disconnect from the controllers. And I'm going to connect to the workers. I wonder with the Windows terminal if that'll allow multiple inputs at once. That'd be kind of neat because you have the ability for the tabbed interface across multiple different shells. So you could have Bash and PowerShell and Command all at the same time. That'd be interesting if you could send the same keystrokes to all those at once. Can't think of anything off the top of my head that would be useful for that, but maybe. Oh, this could take a while. Oh, and I hear a little hacker waking up, so he's going to come help me do this. Oh, and it looks like updates are done. It's amazing. Okay. SOCAT. I don't know that I've used SOCAT before. Socket cat? I don't know. What do you think? I don't know. I just don't even know. Alright, so we need the worker binaries. So these guys are getting Crystal? I don't know what that is. Okay, it's running something. It's grabbing something directly for Kubernetes the Hard Way, so that's interesting. Run C for containers, yeah. CNI, yeah. Container D, kube control, kube proxy, and kubelet. Hey, kube proxy, it's the only one with a hyphen in there. That's kind of weird. That's just weird. I wonder why they did that, Okay, I'm one-handed now. This would be good accessibility testing. If you make a website that somebody can navigate effectively while holding a baby in one arm, you've done something right. Yeah. Okay, we got a bunch of different directories to create. You're still waking up, huh? You've got lamb all over you. He had some lamb pasta for lunch. He has a very interesting palate. Okay, so we're going to move all these things. It's the longest way possible to move that file and make it executable, but I'm not one to judge. Like, I don't even understand half the stuff they're doing, so how am I going to criticize how a file gets renamed and moved somewhere else? That's piddly stuff. Piddly. Okay, we need to configure CNI networking. What's up, dude? Checking out the metal? Yeah. Yeah, you like the metals, don't you? Do you want one? What one do you want? Tell me. Which one do you want? I don't know. You're not getting any of that stuff. Yeah, it's just not going to happen. Here. Where's one of the fun metals? Here, you can have the caramel marathon. It's nice and spit that. So fancy. It's bling-tastic. Do you want to take it and go play with Legos? I'm not going to be over with you. You could eat all the Legos you want. I wouldn't even know until I change your diaper tomorrow. Oh, I see. You want this one. Oh, yeah. Yeah, the river one. The river run with all the colors. All right. This is kind of an awkward posture. Oops, didn't want all that. Pod cider. What is that even doing? That's my eye, dude. I want to see what this thing is. POD CIDR. But how did it know? How How did it know? Like, is that just a generic thing? I don't know. I don't even know. Well, I'm not going to scrutinize it too much. I am working one arm down right now, so... What are you trying to do with the metal? Yeah, you like that one. Yeah, I don't know if I'm going to do that race this year. We'll see. Okay, we want to create a bridge network. So for the container networking interface, we're going to say create a bridge named bridge CNIO 0. Okay, using a subnet of the CIDR that it grabbed into that variable. Oh, what are you doing to me? Ah! Oh, do you need to wear it? Do you want to wear it? Or is that going to freak you out? I'll just let you keep doing your thing. Okay, loop back network configuration for the CNI. Okay. I don't know why that is. Yeah. It's just saying, looks like it's just telling it what version of CNI to use. I'm saying that like I know what CNI really is. Do I? No. No. Container network interface, infrastructure, something like that. Probably interface. Okay, container D configuration. So this is to run our actual container images, Luke. I know. It's a big deal. It's kind of important. Gotta make that folder. Wow. I really wish I had a way to type these commands once right now. It was annoying before. Now it's just a big time problem. Yeah. Do it. Sometimes I need a drink, you know? It's just like, it's hard. You've been working hard, flinging my metals around. Yeah. Why is this one a T? I'm guessing different people wrote different parts. But anyway, container D, type is Linux, default runtime, untrusted workload, and gvisor. Okay? Okay, I'm going to add container D to the startup services. What do you think about that, Luke? Isn't it great to be able to have stuff start when you start your computer? It's so wonderful. Except sometimes you get stuff on Windows that starts and you don't even know why. You don't even know. You're just like, I just wish I could see why all these things start. I wish I could see a definitive list. Yeah, I totally get it. Okay, so we're moving some certs around again. There's a large percentage of the commands that I have done have been related to moving certs. Like not even just the creating the certs, but just moving certs. Do you like to move it, Luke? Do you like to move it?
I do.
Oh, well, thank you. Yeah. Yeah, Mommy and Daddy ran this one. Oh, this was 2016. That would have been after Noah was born. As we were thinking about the possibility of you. Yeah. Okay, so we are creating Another YAML file telling it where some certs are. There's that 10.32 again. It's saying at port or at 10.32.0.10 is where the clustered DNS is. So that's interesting. I wonder, is that the new... Oh, I've heard about core DNS. Do you think it's core DNS?
Yeah.
Yeah, I think that's a good call. Probably. Honestly, I don't know how old this documentation is for the hard way. I mean, my understanding is the easy way has been updated so that it uses core DNS. Okay. Haha! See, if Daddy would have read just a little bit more, I would have seen right there, core DNS. You know what else I'm going to do real quick? Slight segue. I'm going to look. This file is... it's pretty old. In the world of containers, that is. Okay. So we're going to set this guy to start up. Yeah. So it's got that socket bound. All the things, man. All right. So that was that. And now we need to configure the proxies. Oh. Thank you. Thank you, Luke. Should I just wear this all the time? Here we go. Yeah. Do you want to wear this one? We can each have a medal. It'll be awesome. Oh, there you go. Look at you. Yeah. You ready? You're going to do a race next weekend. Yeah, we're going to do the Michigan Mile. It's going to be fun. Okay. So we've got to do some more moving of configs. No. Get back up there. What are you doing to me? Oh, okay. Well, I'm going to set that there for now. Sir, I believe you've had enough to drink. Yeah, I don't know. I just don't know. You know, I don't mind you sitting in my lap. It is slowing me down significantly. But if you wanted to get down and go play with something, would not break my heart. Just saying. Okay, so we've copied some configuration around. We've created a YAML to point at that configuration, telling it that cluster cider. Done. Yeah. Is that where you wanted it? Did you want to go get it? Or are you just staying here? Okay, so we're going to create a service, create that, make it so that that proxy service starts when the system's started up. And now we're actually going to start it. Okay, so that's going to load containerd, kubelet, and the proxy. Okay. don't know what you're doing. Did you want down? Do you want down, Luke? No. We can just keep cuddling. That's fine. Just kind of a weird. There. People can see a little bit of you. Okay. So. What are you doing? No! No! Luke, can you please not? Okay, so we're going to say get nodes. They're having to do it some weird way. So I'm going to just do it on this one node. Okay, so it's going to look at the admin kube config. Say get nodes. Oh? Interesting. Oh. Daddy silly. I'm on one of the workers. I wonder if I can SSH from a worker to the controller. Maybe. What are you doing to me, Ninja? Oh, it's creating a key pair for the first time. Oh. Did you mean zone? Why, yes, I did. Thank you very much. Oh, let's not play with that, Luke. Hey, you got those big blocks that you like back there. How about you go get them? Yeah? Take a quick anonymous survey. No, I'd rather not. Okay, so from the controller is able to see worker 0, 1, and 2 already with no roles. Age 2 minutes and 24 seconds. All right. Okay, in this lab we'll generate config, so admin user credentials. So I'm assuming that this is how I'm going to be able to use kube control from my machine to reach over into these workers and such. API server. Okay, so we're going to generate kube config for authenticating as the admin user. Okay, and I'm doing this back on my machine. And so I'm saying connect to that public IP using my certificate authority with the admin key pair. Oh yeah. Got a doggy. Doggy. Yeah, you think that's funny? Here. Do you want to take him? Or do you think he needs to stay with me? Yeah. If that's how you're going to treat a dog, you're never getting a dog, just so you know. Okay. Kube control, get component statuses. Oh, that is so exciting! Luke. Okay, yeah, celebratory music. Rock out, man. So we've got a controller manager, scheduler, etcd. Actually, I want to say that was what we saw before, but we must have been doing that from the cluster. So that's cool. We're able to just do it from our machine here now. Yeah, you kind of knocked over the guitar. That's okay. Did you need me to fix the guitar? Yeah, it's easier to play if we move it this way. Whoa. There you go. Okay, and I just broke the hydraulics in my chair. Alright, much better. I'm taking off this ridiculous metal. What's up? What's up, bud? Okay, now we can get nodes. Worker 0, 1, and 2, they're all ready. We did it from the controller node a second ago. Now we can do it from localhost. My localhost. My laptop. Outside the cluster. The definition of the remotest of remote access. Okay, pod network routes. Okay. Actually, I should probably look at how many things do we have total to do. So we are on 11. Oh, Luke, we are so close. We are so close, man. Okay, we're gonna set up a routing table here. So pods scheduled to node. Okay. Receive an IP address. At this point, pods cannot communicate to other pods due to missing network routes. And this lab will create a route for each worker node. Okay, so this is... Okay, so we're less Kubernetes specific now and more in the realm of just generic networking. Oh, you need this on.
Hi, I'm Scout.
Do you? You needed your laptop. He needed his. You know. He's right. I know that my laptop just it's not easy to use for your hands. Okay. Yep. So we've got those noises going on now. That's great. You're a little bit ridiculous, Luke. A little bit. Okay, so we're going to create routes. Kubernetes route 10, 200, 0, 1, and 2. Next hop address 240, 20, 21, 22. Okay. Yeah. I'm definitely gonna have to go back and map out these subnets later on to make it easier for me to understand exactly what's being used by what. But we're gonna set that up. Okay, and we're gonna list the routes that we have.
Press the paw button to pick
Oh,
a tune.
it's not done yet.
Let's learn about numbers.
Yeah, I need to learn about numbers.
Mode.
I need to learn about patience too. Yeah.
Laptop. Hi.
Okay, so it's looping through. It's done the 0, it's done the 1. Now it's doing 2.
To pick a tablet. Let's play.
Should be done any moment now.
Tap the music mode to keep the music laptop.
Okay.
Tablet. Let's play some music.
So we've got a lot of routes now.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Interesting.
12, 13, 14,
So it's got the 1 on the 240 subnet, and then 3 different ones on the 200. Okay. I'm just gonna have to muscle through this because we are almost there. I can only do so much with Scout, the learning puppy there. Okay, deploy core DNS. Okay. So we're going to push that core DNS container out there into the world. Awesome. So we've done our first apply. Okay, get pods. List the pods that were created. Okay, so it created 2. That must be something in that configuration that says it needs a replica of 2. And create a BusyBox deployment. Okay. V1 Beta 1 is deprecated. It will be removed. Okay, use kubectl create instead. Interesting. Okay, list the pods created for BusyBox. So we've got the pods for kubeDNS, core DNS stuff. Listing them a little different this way. So here we did -L Kubernetes app equals kubeDNS namespace kube system. I'm definitely doing some guessing here. So I'm guessing this is a key value pair for the way that the tags are created, or the labels, whatever they call them. And so here we've got run BusyBox versus Kubernetes app kubeDNS. And here we're not specifying a namespace. I'm assuming that this is a namespace. But it created one instance of that. Okay, and we can grab the full name of the pod. And it's going to look that up against the Kubernetes names. Okay, so it's on, and there's that 10.32. Okay, so it's actually creating stuff running within 10.32. So that's where it is on 0.1. Yeah, they've got 10.32 there too. Okay, we're going to smoke test this thing. We are so close. Okay. In this section, you'll verify the ability to encrypt secret data at rest. So we're going to create a generic secret. So I've heard that, so this is the internal Kubernetes secrets versus I know you can use Vault instead, and there are some advantages from what I've heard. So create a hex dump of the secret that we just created. So I'd better not use my key, my data for anything special, because somebody's going to see it now after I give my key. Okay, and it's got a path, so similar to some of the stuff with Vault, you've got kind of a path for it, and then a value. Okay. So I'm assuming everything after key 1 is the actual secret that it created. Yeah, because they've got key 1 as well. etcd key should be prefixed with K8 encoded AES CBC v1 key 1. Okay. Okay, deployments. So we're going to deploy Nginx. Now for the other one, when we did kubectl run with create, it said that was being, or with generator, that was being deprecated in favor of, yeah, up here, use kube control create instead. We'll see what it does when we say run nginx image nginx. Same thing. Yeah. So kube control create is the preferred verb, if you will. But for now, it went ahead and it did it. I hope Luke isn't breaking something right now. Okay, again, we're doing the key pair of run and nginx. And we see there's one instance. Okay. So we're finding the nginx pod, grabbing that name with some metadata .name. So I'm assuming that's just that first bit. If I look at this pod name, yeah. So it's just that first part. So I had to get that same information as JSON, but said give me this particular element within there. Okay, so we're gonna say port 8080 on my machine. Oh, you're gonna give everybody a concert? That's awesome. So 8080 local is gonna go to 80 on the pod. And in a new terminal. In a new terminal? Oh, because this is still running. That's why I have to have a new terminal. All right. Swing back to the previous terminal and stop nginx. Most exciting part of all this. Let me get that dramatic music going as well. Okay, so we're done there. Now we're going to look at some logs. So I've got pod name still in a variable. Okay, saying that it had an agent of curl. I had a request, or just had slash. Cool. Okay, in this section you'll be able to verify the ability to execute commands. So print the nginx version by executing nginx -v. So we've got exec ti, assuming that's terminal input, something along those lines, to the pod name, doing that double hyphen, used to that for node. Alright, so we can run a command remotely. Okay, in this section you'll be able to expose applications using a service. You're on that bike backwards, you know. That's alright. Okay, so we're going to expose nginx on port 80. Okay, saying that that's the node port. So I'm assuming that that's, versus a container port. It's saying do it for the whole VM, for that worker node. Load balance service type cannot be used because your cluster is not configured with the cloud provider integration. Okay, so cloud provider integration would tie it into the actual load balancer, I'm assuming. Retrieve the node port assigned to nginx. So get service nginx. I actually want to see what that looks like if we just do this. There we go. Name Nginx, type node port. It's on that 10.32 0183. I don't know. So it's port 80 local, or externally port 31936 locally. All right. Create a firewall rule to allow remote access. So that node port. We're going to create a firewall rule for that. Yeah, you found a tire. How about you go ahead and build me a car over there? Okay. So that 31936 port. Oh, I hear some banging up there. I think Mom's home. So we've got an external IP address of 35.237.81.20, and we've got a node port of 31936. So now we're going to curl the base of the Nginx server. Boom. Looking good. Okay, untrusted workloads. So we'll verify the ability to run untrusted workloads using gvisor. And so gvisor, I heard a podcast about that. That's where it sets in between your containers and any syscalls. So we're going to kube control apply -f untrusted workload hello world. So hello world is the untrusted workload, and we're going to grab that from Hightower Labs. Okay, so it created a pod of untrusted. Yep, and there's that get pods -o this time instead of -l. So we've got BusyBox Nginx, and then we've got just untrusted. And notice that DNS guy, he isn't there because we didn't give that namespace of system. That's at least the theory I'm working with. Okay, so we're going to grab instance name. This is probably something I already have on the clipboard. Well, actually, I don't know that for sure because I don't know what instance that's on. Oh, it's on worker 2. So we're going to SSH to worker 2. Are we already connected to worker 2? We are. Look at that. We are. And then list the containers running under gvisor. So run sc. Run sc. Kubernetes IO. IO. Okay, I don't see anything that would remind me that it's hello world. And we're going to get the ID of the untrusted pod. We're going to look at what the name of that is. 6936. So that was this one. Again, nothing's making it obvious to me that that's the hello world. I'm going to get the ID of the web server. So we've got the container ID. Okay, run sc with that container ID. I'm still not seeing anything that makes me recognize that, oh yeah, that's that hello world that I grabbed. This is probably all a big scam. Kelsey Hightower, he's probably scraping some, or mining some Bitcoin right now using my amazing N1 machine out there. Okay. Okay, I need to understand this a little more. So we grabbed the container ID. Crictal did that. Looking at the sockets on that pod, and that pod we grabbed because we were looking for that name of untrusted. That must be that when we said untrusted up here, we must have named it untrusted. Yeah. Okay, now I understand. We said create a new pod of untrusted, and within that have the container that's a web server using the image hello world. Okay. Now it's making a little more understanding to me. We kept talking about untrusted as both a concept and a name there, so it was throwing me off a little bit. Now I'm back on track. Wow, we made it to the end. So let's do some cleanup. So deleting all those VMs, which, why don't I go ahead and just disconnect from them first, just cause. Oh, yeah, and I was actually going to do that from, I don't know how well that would have worked. I'm trying to do it from one of the workers. There, we've got a bunch of extra stuff open now. Okay, so we're going to go ahead and delete all those things. Now granted, when I was provisioning VMs for Windows, or for Azure, they were Windows VMs, and so I'm assuming that their images would have been a lot larger than just Ubuntu, but at least creating the nodes was so much faster using Google Cloud. But I didn't do many Linux nodes with Azure, as in approximately none, other than a couple just quick tests. Okay, gonna delete the external load balancer once we get a chance. I'm assuming there's an order you need to do these in. Oh. I'm assuming it's one of those things where if you try to delete a network-based resource that is tied to some compute resources, it might fail. So I don't know why I did that. I'm just going to do it here. It's because I want to do this serially, just because I don't know what's going to happen if I try to delete them out of order. Okay, so we're deleting everything that we'd created kind of backwards, except that the load balancer, I think, was the last thing we created. It would make sense that we would delete that before the firewall rules. Yeah, my guess would be I could have deleted the load balancer at the same time as the nodes, but we didn't. These last bits should be faster to delete anyway. And now we can delete the actual VPC. Should be just about done. All right. And all in the nick of time, because it sounds like I'm about to have to go punish one of the kids. I hear him up screaming. Come on, gonna make it. Gonna make it. All right. I mean, that's it. You know, so I went through Kubernetes the hard way. It took us a little while to get through it, but it wasn't bad. There's some pieces around like that magic 10.32 subnet. I don't know where that came from. I don't know how that came to be. So I'll need to research that. But I mean, ultimately, the one thing that really stood out to me from doing this was just the pure number of certificates involved. So, other than that, I guess next time I'll just try to use some of the. I'm trying to think of what the tools are, but they're the Kubernetes setup scripts that you can run where it's just a single script and it does all that for you. Which, I mean, obviously, there's nothing we did that wasn't scripted other than what I did before I started recording, which was setting up my Google Cloud account. But yeah, that's going to be pretty straightforward. Yeah, hopefully this was beneficial for somebody. I feel like I learned a little bit. But anyway, that's it for me.